Sanjay.
Good morning.
How are you, bro? So, time has begun. Let's start. Okay. Are you ready?
Yes,
Okay. Let's start with Faraday's law and Lenz law. What are Faraday law and Lenz law?
Faraday's first law of electromagnetic induction states that whenever there is a change in flux linked with a conductor, an EMF will be induced in the conductor. And Faraday's second law of electromagnetic induction says that the amount of induced EMF will be equal to the rate of change of flux linked with the conductor. Induced EMF small e is equal to d phi by dt.
Yeah. Okay.
And Lenz law tells about the direction of induced EMF. It tells that the induced EMF will always opposes the change in flux. E is equal to minus d phi by dt.
Always opposes the change of it says that always opposes the change of change of the causes of producing it. No.
Yeah.
Okay. How does three-phase induction motor work?
The two main parts of three-phase induction motor are the stator and rotor. When we supply three-phase AC supply to the stator, a rotating magnetic field will be produced in the stator. This rotating magnetic field will touches the conductors in rotor.
Sanjay,
So, according, yeah.
start with like three phase means three phase of line 120-degree, and it's work on Faraday's law. So start with there. Three phase means three phase of line, na?
Yeah, but I don't know the angle 120 degree. What is it?
120-degree. The supply is 120 degrees, so total 360. No, 120, 120, 120. So the winding in this way, that is 120 degree.
The windings in stator.
Yeah, yeah, in a stator.
Okay, in stator there will be three windings.
Yeah.
The angle between the windings will be 120 degree. Okay.
And continue working.
Should I start again?
Yeah, yeah.
The two main parts of the three-phase induction motor are stator and rotor. Uh, when three-phase AC supply given to the stator, a rotating magnetic field will be produced in the stator. The stator contains three set of windings. So each phase will go to each winding. When current passes through a winding, a magnetic field will be produced. So a total of three magnetic field will be produced. The resultant of three magnetic field will be this rotating magnetic field. This rotating magnetic field produced in the stator will touches the conductors in rotor. So according to the Faraday's first law of electromagnetic induction, an EMF will be induced in the rotor conductors. Then according to Lenz law, this induced EMF will opposes the relative motion between the rotating magnetic field and rotor. So the rotor starts to rotate in the same direction of rotating magnetic field with almost the same speed, but a little less than the speed of rotating magnetic field. This is the working of three-phase induction motor.
You said they will rotate with the same speed.
Almost the same speed, but not equal speed.
Okay. Like, what are the speed in synchronous and asynchronous motor? The synchronous motor rotate at synchronous speed, and asynchronous motor rotate below synchronous speed. Not. Uh, so induction motor is a synchronous motor or asynchronous motor?
Three-phase induction motor is an asynchronous motor.
So can we say that it's rotate at the same speed?
Bro, I told that the rotor and the rotating magnetic field will rotate almost the same speed. There will be a little difference between the speed between rotor and rotating magnetic field.
Okay. Okay, next question. Difference between synchronous motor and asynchronous motor. What is the difference between synchronous motor and asynchronous motor? Don't know. Okay. Working of alternator and generator. Okay, what is armature and field winding? First, let's know. What is armature and field winding?
I don't know.
Armature is the winding where the current induced, and field winding is the where the magnetic field induced generate. So in alternator and in generator, both have armature and field winding, but in opposite. So in alternator, the field winding is in rotor and the armature is in stator, and it just opposite in generator. Okay, so it means the current induced in alternator in stator part, and in generator the current induced in rotor part. Okay, so these are the two main difference by in rotor and stator. Okay, so maybe these are the important point according to me, where armature and where field winding. So if it what are the working of alternator and generator?
Bro, can you once more tell the difference between alternator and generator?
Like
Alternator and field winding.
yeah, the difference the best difference between alternator and generator is it's a field winding and armature. So armature is the part where the current induced. Okay, and field winding is the part where the field winding where the magnetic field generate. In alternator, the armature is in stator winding and the field winding is in rotor, and just opposite in generator. Okay,
Okay, okay.
yeah. So it means a current induced in alternator in stator part, and in generator the current induced in rotor part.
Okay.
Okay, so now what are the working of alternator and generator? Do you know alternator working and generator working?
No, I don't know.
No, bro.
You know? Okay. So first we take talk about alternator working. In alternator, uh, the rotor of the alternator when we start rotating, so it induces a changing magnetic field. That changing magnetic field induce EMF or voltage in stator winding. Okay, so in this way the alternating current induced in alternator. Got it? And we know that alternator used in vehicles, so we cannot use AC, so we need DC there. So there is a rectifier that convert AC into DC for vehicle equipment. Okay, bro.
Okay.
Okay.
And in generator, when the rotor of the generator start spinning, so the so it cuts the magnetic field generated by the stator. So because of this, an EMF and voltage induced in rotor winding. As we talked about why it's happened, because of the armature is in rotor, that's why the current induced in rotor of the generator. and both work on Faraday's law of electromagnetic induction. Three-phase induction motor and alternator, generator, transformer all work on Faraday's law of electromagnetic inductions. So you can, before before saying the working principle, you can add 2 points. It work on Faraday's law of electromagnetic induction, and if there is motor, so it convert mechanical energy into electrical into mechanical, and alternator and generator uh, sorry in alternator and generator it convert mechanical energy into electrical energy, but in motor it electrical into mechanical energy. So add 2 lines also. Okay, we talk about rectifier. Rectifier convert AC into DC. Okay, in induction motor there are 2 types of rotor. Do you know what it's? 2 types of rotor we use mostly. The 2 types of rotor is squirrel cage rotor. It is induction motor, and the second is wound rotor. The difference is, in a squirrel rotor, you can see the picture on Google. In a squirrel rotor, there is a bars, the rod bars, and in wound rotor have a winding. The same winding is in stator. The same winding is in rotor also. In induction motor. Okay, what do you understand means slip ring? What is slip ring and brush? What are the function of it?
Bro, can I ask a question?
Yeah, bro, ask.
Uh, can you please explain the difference of the DC motor and AC motor
DC motor and AC motor.
and working also?
Motor. DC motor, like the small that we use in electronics are the DC motor, and the AC motor we use in daily life, domestic purpose and industrial purpose. But the working is, I think in DC motor we use permanent magnet, and in AC motor we generate magnet, which is called magnetic field. Okay.
Okay.
Yeah. In DC frequency is 0. Okay. Okay. What are the frequency? Okay, we will ask in next questions. Next question is, what is transformer and its types? What is transformer and its types? Working of transformer parts and its types.
Transformer is a device that is used for the transferring the voltage from one store to one device to another.
Yeah.
Transformer is to mainly classified into step-up transformer and step-down transformer.
Yeah. So it's better
It is
from
main,
one place to another place, say from between 2 circuit or more circuit. It's better,
okay.
and it also work on Faraday's law.
But I heard the mutual induction is also used here, right?
Mutual induction uses in induction motor also, na. Mutual induction
Yes.
means from one like it adapt from stator to rotor, rotor to stator, RMF, EMF, magnetic flux, then EMF. So I think these are the mutual. What is mutual induction means? Faraday's law work on mutual induction, and Faraday's law also used in all the equipments. So I think mutual induction is everywhere, no? Can we say that, like in mutual induction? So we can see that in Faraday's law mutual induction happen. And we also know that the all equipment work on Faraday's law, like alternator, generator, motor, and transformer. So it means all work on mutual induction. Can we say that? I am not sure. That's why I'm asking.
Three-phase induction motor also use Lorentz law, I think. What is Lorentz law?
Lorentz law? I don't know Lorentz. First time I heard Lorentz law. Is it electrical law?
Yeah, I think.
What do you know about this? Do you know about this?
I don't know, bro, correctly, but I heard the Lorentz law is used in a three-phase induction motor. So
Just
that's why I asked.
whatever you know, you can at least tell so we can know. Not exactly, no problem.
The whole torque is induced, no?
Torque.
So torque is induced by Lorentz law, I think.
I'm not 100% sure, so I write it down. Okay, so you are saying about transformer, so please continue. So you told transformer work, and two types of transformer: step up and step down. So what is step up and step down transformer?
Step-up transformer is a device that is used for the increase in the voltage. For example, if we use the oven which was on the 2000 volts, our supply is 230 volts only. So we step up the voltage and increase the voltage and give it to the oven. That is main use in the step-up transformer. For in the case of step-down transformer, so if you use the mobile charger, just mobile voltage is about 5 or 3 volts. Then we have to step down this voltage. So we use step down voltage. If the main transformer is mainly consist of the two windings, primary windings and secondary winding. In secondary winding has some more windings, more number of coil. That means it is step up transformer. If the secondary winding has less number of coil, that means it is step down transformer.
Yeah, you are correct. The example you give here is very well in charger and the oven. So we know, yeah, Gotwami, vice versa. So it means if we have a transformer and we want to increase voltage, so means step up. So just we increase the number of coil in the secondary winding as compared to primary winding. And if want to make a step down transformer, so we decrease the number of winding in secondary winding as compared to primary winding. Is it na, Vishnu?
Yes, bro. Yes.
If interviewer asks what are the frequency and voltage reach at our home, frequency and voltage, what frequency?
230 volt. 230.
220 na?
I heard that it is 230.
230 to 250. Actually, I heard that the it depend on country. In India, we receive 220. That's why everywhere you can see the 220 volt. In motor also 220 everywhere. But in other countries it will change. In India, I think 220. Why it's
Voltage is 220
because
and frequency 50 hertz.
yeah, frequency 50 hertz and voltage is 220. And why it's
Yes,
changed because
this
depend.
is varying in countries. In our country, the British era is implemented 530 230 volts, so we adopted that.
We can confirm on Google if you want. Let's share the screen and try to. screen showing to you? About
Yes, bro.
Paiju's answer is 220. The standard voltage for household in India is 220 volt.